Good morning, everyone, and welcome to this keynote session of the Joint Journal two-day conference for the Journal of Online Learning Research and Practice and the International Journal of OERs, focusing on AI. I'm Kathleen Tate, PhD, Editor-in-Chief of the first mentioned journal and Professor and Department Chair of Teaching at American Public University System. It is my honor to introduce keynote speaker Dr. Matthew Leese, Professor of Information and Computer Science at the University of Texas at Austin. He has an extensive bio that you can see online, but a short introduction is that Dr. Leese is faculty founder and leader of UT Austin's Good Systems, a $20 million 8-year university grand challenge to develop responsible AI technologies to address societal needs. His research combines artificial intelligence and human-computer interaction. Dr. Leese's keynote session title is Generative and Responsible AI in 2024. It is my pleasure to turn it over to Dr. Leese.
Thank you so much for such a lovely introduction, Kathleen. Hi, everyone. Really nice to be here today. You've got my title already. One note is my slides are available. They've just been posted in chat. So in case you just want to follow along there or have a copy, so you don't need to take screenshots or anything. They're also recording this, I think, also, so you can watch later. Well, I'm thrilled to be here and talk a little bit about AI. As you see here, this is a big year of AI at UT right now. It's for a lot happening for us. And I'm happy to have a chance to tell you a little bit about some of that and some of the other things happening in the field right now. So organization for my talk today, I'll tell you a little bit about generative AI, which people I know are particularly excited about, some of the capabilities, excitement, and hype around them. Then we'll go back a little bit more to talk about just sort of defining AI, how it works, some of the challenges. Then I want to shift gears a little bit and talk about this responsible AI Kathleen mentioned. So we have this big endeavor to try to really think about how is it that we build, design, test responsible, ethical AI systems. And then I'll try to talk about one project as time allows, specifically where we're looking around information literacy and how we can be thinking about AI threats and opportunities for protecting our information environment. So to get started. So generative AI, it's all around us today. We see things like we can ask it to write a sonnet for us and it will be happy to craft something creative. Or for instance, we could have it imagine a painting of the Dallas Cowboys winning a Super Bowl and what that might look like. So it's not just a toy, it's made it into our productivity applications. So for instance, here, if you're using Copilot and Microsoft tools, you can do all kinds of very useful things now that make it, sort of accelerate your work. A lot of this comes with starting with writing prompts. So with a prompt, you sort of say what you want the generative AI to do, and there's a lot of details you might put in. And there's this whole art now of how we sort of write and craft these prompts. And it's gotten so popular, there's now marketplaces where you even can go and buy prompts that people have created at work, or sell your prompts if you're a prompt artist and you're able to create these effective prompts. And so there's just this sense of such excitement and opportunity that these things seem to do anything. And so sometimes you hear terms bandied about like you see on this slide. So artificial narrow intelligence is what we've typically done for a long time is we've made AI to do specific tasks very well, but it's a lot of work to make it for each different task and they usually don't generalize well. One of the neat things about these generative technologies is that often it seems like, you can just by crafting this prompts, like we were just talking about, have the same tool do a lot of different things really useful. And then there's this excitement about super intelligence that you hear about in all the sci-fi movies. Will the system be better than we are in many ways? I'll talk about some of the ways it's maybe already better that we maybe don't think about as so exciting, actually, and some of the ways that might help us think about demystifying what we talk about when we talk about sort of exceeding human intelligence. One thing I really want to draw attention to is we have a long history of hype cycles in AI. Everyone in the media, of course, loves to talk about all this stuff. The sci-fi movies love to talk about it. And often we have expectations that ultimately aren't met, and it leads to these troughs of disillusionment. So we've had a couple of these AI winters in the past. And one thing we really want to do as sort of AI experts is help people set reasonable expectations such that we don't have any kind of trough like this again in the future. So just sort of getting a little teaser stuff to get started, let's talk a little more about AI, how it works, and some of the challenges we have. Okay, so for artificial intelligence, that's sort of the big umbrella that people talk about, the sort of broad science and engineering of making intelligent machines. Within AI, what we typically do a lot today is what's called machine learning, where we're learning patterns from data. I'll say more about this, but you might think about this as like trying to classify your email between spam versus good mail. Deep learning, you've heard people talk a lot about, which we'll again we'll say a little bit more about, but this is sort of building these neural networks. These models get bigger so they can do a little more for us. And then sort of generative AI. So these are all sort of kind of sub components within AI at large. So what's artificial intelligence? Again, science and engineering of trying to make intelligent machines. So sort of automating intelligent and cognitive tasks. So if you think about the Industrial Revolution, we automated a lot of tasks that we did physically. Now we're trying to automate a lot of the tasks that we sort of used to do virtually. Artificial intelligence actually goes quite back far. It's 1956, let's say. Concepts even go back farther. So even though we hear so much about it right now, this really is a long history here. So I want to talk briefly about something called the AI effect. So if you look up the word computer in an online or physical dictionary, you'll see one of the archaic definitions of computer is a person who computes. Well, before we had machines to do any of this, that's what computers were. People who were doing, for instance, performing math calculations that made tables that we had in the back of books. So today, we've automated all of this because we don't need people to do it anymore. In fact, calculators can do big math a lot better than any of us can. So would we consider those calculators as AI or super intelligence? So this AI effect is the tendency to keep redefining AI as anything that hasn't been done yet. So we continually move the goalpost for what we consider artificial intelligence. And so as somebody well put, once something becomes useful and common enough, it's not called AI anymore. We just sort of see it as like a useful tool in part of our environment. There's a sort of funny notion about what it is that we conceptually think about as AI. So about 15 years ago, when I was a graduate student, I went to a talk by ETS, and they were already doing automatic grading of student essays for SATs or GRE or something like this. And that was 15 years ago. That was AI technology to do this automated grading. Would we think about that so much as sort of exciting AI today? There's a long history of a lot of AI doing useful things for us, and it starts to disappear sort of into the fabric of our lives once it sort of becomes routine and automation. So for machine learning, broadly we can think about this as learning patterns from data. So I mentioned before an example of determining between whether email is spam or ham. You might think when you go to buy products online, they might suggest products. You might go, or if you're trying to just get Google directions to your favorite destination, when they can suggest how long something will take. This is all just learning patterns from data. And this stuff is statistics at the end. It's sort of not very sexy, but when you collect a lot of these statistics, you can actually make pretty good predictions about what's going to happen in the future. So AI is really data driven. So when you've heard people talk about big data, in general, the more data there is to learn from, the better AI can perform. Just think about if you're trying to collect some statistics to make a prediction about the average height of people in the United States. The larger the sample size, the more accurate your prediction will be. So with a source like the web, where there's so much information being posted all the time, it's a really great resource to try to learn from. So big data. We also talk about bigger models, and this is where you hear about deep learning. So usually the bigger the model is, the more we can learn. So you might think about this as a more complex statistical model. The more parameters you have, the better you can fit the data. The quality of our data also really matters. So one of the adages we talk about is garbage in equals garbage out. So we want to be thinking about all these kinds of things, the size of the data, the quality of the data, and the size of our models. And I'll say a little more about each of these. So one thing you hear a lot about today is large language models. So these are these models that are trying to do really good like generation, like we saw the sonnet earlier. But there's a long history of language models that kind of predate this. In fact, language models go back to the early 90s when we first started trying to do speech recognition or automatic machine translation. So really what's changed again so much since then is just really the scale of the data, the scale of the models, and a few tricks we've learned about tuning these things, but sort of the concept is quite old. And we'll see in a minute what a language model really is. So as I mentioned, data quality is really important. So if you take a resource like the web, there's lots of data on it, but also lots of bad stuff that people have posted also. And so we talk about two kinds of key mistakes that an AI might make in a prediction error: random error or consistent bias. So with random error, if you see enough data, it'll cancel out and it'll go away. But the problem is that when we have consistent bias, you keep seeing the same thing over and over again, you can actually amplify that bias from the scale of data. So one thing we try to think about in what's called data-centric AI is really maybe just fixing the model. Models are really going to be commoditized. They're sort of things that you can just use often, but really curating the data to make sure the data is creating the kinds of model predictions that we want to not have the sort of bias that we might worry about. So two concepts I want to say, and I'll give examples, are unsupervised versus supervised learning. In education, terms like these and active learning mean very different things than they mean in AI. So just drawing that out. But so unsupervised learning here is when we have our machine learning model try to just find patterns in the data without any human intervention. And again, this might be examples like seeing how long it takes to drive places, typically seeing what books tend to be bought together, for example. In supervised learning, we're trying to get the AI to make specific distinctions that we think are of interest to us. So let's look at an example of unsupervised learning here from web text. The way these language models work is basically they're trying to guess what words are appropriate around certain context. So if you look at a lot of different text on the web, you'll probably see examples where a cat goes to a litter box, but a dog doesn't. And a cat will go to a litter box, it won't go to a penalty box. So in this case, there's no human supervision involved. We're just looking at lots of examples of text on the web and seeing what words tend to go together. Part of the problem that generative AI is running into is when you're trying to learn from a data like the web, not everything on there is open domain and free to use. So there's concerns about, for instance, say particular creative artworks or texts, being reproduced by these models. And there's a lot going on right now in terms of the courts, people trying to sort of settle this out. But that's one of the challenges when you just sort of try to train on everything, as well as some of the problematic content. So in terms of like supervised learning, so this is now where we go to people and we say, okay, well, if we just have the model predict which words go together on the web, here are the things it sees, but maybe sometimes some of those words we don't want to have come out. So for instance, I said there's bad stuff on the web. So we might want to have supervision where we tell the model, yes, you've seen that those words go together on the web, but please don't produce them when I use you in practice. There's a lot of this work on alignment right now about trying to make sure these models produce appropriate things. I'll say a little more about that too in a minute. So one of these examples, there's many, and I'll just start with Microsoft, but many others. When people were first trying to deploy these tools, if you think about for supervision, you put a chatbot on the web and it learns from anything people say. Again, some people are going to say bad things to it, just like people write bad things on the web. And so here's an example that if you don't take a lot of care and you just reproduce the things you get, supervision can actually lead you in a bad way. Other things to think about are if we want to have human supervision, still there might be bad stuff that people have to look at. And how do we think about who does that work for us? If we're outsourcing that kind of work to the third world, sort of like people talk about digital AI colonialism, where we sort of maybe take advantage of people in other parts of the world to kind of filter some of this stuff to create the experiences for us, here in the Western world. So one thing we're trying to think about when we talk about responsible AI that I'll say more later is thinking about all the people involved in the supply chain of bringing the AI to us. If AI is very data centric and the data matters, what's the role of all the people who sort of curate the data for us or curate these systems to make sure they give great experiences that delight customers, but also take care of the workers involved in the supply chain up to that point? Okay, so I gave you this opening example of AI writing text, for instance, a sonnet. So maybe let's go a little bit and see some of how this works. So here's a fun game. I normally play this interactive with audiences, but we'll do it without interaction today. So what word am I thinking of? Pretty hard to guess right now because there's no context. Okay, I'm thinking of the word Monday. Now, I've told you I'm thinking of Monday. What's the next word I'm thinking of? You'll have a little better idea, but still pretty hard to guess. Like I could be thinking of breakfast. I mean, who knows? But I'm actually thinking of the word night. So I'm saying Monday night. Okay. Now, given that I've thought of Monday night, can you guess what the next word is? People do very good at this one, actually. So football, right? Right. And so if you just like look at the web, you see that these words often go together. That's why you can generate this so well. But let's not foolproof. So again, if I go to Google and I type Monday night, Google will probably also guess I'm thinking about Monday Night Football. But if you're in Atlanta, you might actually be thinking of Monday Night Brewing, which is a local bar or beer company, something that's really popular. So this is basically a guessing game where you're playing the probabilities, the odds, and you can often get it right, but you might get it wrong. And we'll see how that can lead to some problems. So for instance, I might ask generative AI, tell me a fact about George Washington. And I might get something like George Washington invented the cotton gin, which is wrong. This was E.I. Whitney. So historically, with like information literacy, when we looked at content online, we could just look for cues like bad spelling, bad grammar, bad formatting, things like this that really help us understand when information was incorrect. One of the challenges with generative AI, because it's always playing these odds and guessing the words based on statistics, is it guesses really well and it produces very fluent content that can be totally wrong, like as we see in this case. That's one of the real challenges we have in sort of making sure that we as users, but also when we're readers, when we're finding content, how we know if what we're reading is actually correct or not. So one of the things we do to try to make this a little better is called retrieval augmented generation. So when we're going to go out and we're going to say, guess that George Washington invented the cotton gin, we might try to go and find evidence online and see if it supports it or not. And if we don't find evidence supporting that, but maybe a lower probability generation about Eli Whitney might actually have really good evidence, then we can go out and make better generations. In addition to that, when we produce those generations, we can actually provide citations or provenance to where this stuff comes from, such that people can actually check and look for themselves to see if this seems correct or not. Another thing to note is these generative models, they're trained for months, but then once this training stops, then they go out in the world. Well, the world continues to change. So if you're asking something about current events, the model won't know it from its generative training data, but through retrieval, it can go out on the web and find more current information to sort of update its knowledge base. Another thing I love to think about is that sometimes hallucination can be a feature rather than a bug. So if you're doing something creative, in this case, they're trying to generate a paragraph for the background of a video game. The fact that these AI models can hallucinate very creative, unexpected things can actually be really fun. And this isn't just for creative writing. If you are trying to do any kind of new product generation or creative marketing or brainstorming of new ideas you might pursue, kind of this sort of hallucination might actually be a really exciting feature. So while we're working a lot on making these models more correct in what they output, I think there's also really interesting use cases of having them sort of think outside the box for us in these sort of hallucinating creative ways. Okay, so we also talked about sort of examples like creating images, which is pretty cool. Here's a fun example again of the Dallas Cowboys, celebrating a Super Bowl win. But there's also these cases that start to feel a little more questionable. Like, for instance, I can take pictures of celebrities and change the gender in such a way in ways that look, realistic. But, then you start to ask questions, well, what's real here? And then it gets a little more problematic when we start to see that, fake images like this generated that really have effects, where the stock market suffers or people get hurt or they decide to make bad health decisions for themselves. So we have more concerns in general that as AI gets more powerful, more ubiquitous, impacting more people's lives, we really need to be careful about some of the potential harms that it can produce in the world. So here I just try to give a couple of examples and show this is not really not unique to any company or research. Really, this is pretty widespread. So I mentioned the Microsoft example, another one for IBM. They spent lots of money on doing this Watson for oncology that ended up pulling the plug on. Apple had face detection, which was fooled by a 3D mask. Amazon had facial recognition that mismatched Congress people with criminal mugshots. So one of the great challenges we have right now is there's so much opportunity and excitement about what AI can do, but also increasing recognition of the risks it bears to society. So how is it that we can, as researchers, design, build, test, but also as regulators, create policy and appropriate regulation such that we can really maximize the opportunities of AI while minimizing these risks? And this is where I want to start to tell you a little bit about some of the work we're doing here at UT Austin, as well as more broadly around what's called AI governance and responsible AI. So about 5 years ago, the president of the university here launched a campus-wide grand challenge to try to build ethical AI systems. So try to make sure that the AI systems we're building embody sort of the values that we want in our technology. So broadly, again, we're seeking to enable development of AI technologies to really maximize these benefits while minimizing risks of harms. So in general, we have philosophers, among others involved, social sciences, we're really trying to think about what are the kinds of values that we aspire to, that we want our technologies to embody, transparency, trust, agency, equity, all that sort of good stuff. So you'll hear a lot of different terms when people talk about, sort of ethical, responsible AI. I just grabbed one graphic here to give you an example of when we talk about responsible AI, we might think about things like fairness. We want to treat all people equally. Reliability, we don't want these systems to fail for us in surprising, unexpected ways. Privacy, we might want the data that these systems are trained on to respect privacy appropriately of people. Transparency, we need to understand enough about how these systems work to be able to use them effectively and know when they make mistakes. Sustainability, I think this is one that gets the least attention, but we're seeing more and more as these very powerful AI models are are using tons of electricity in data centers. What are the impacts of climate change or brownouts or things like this that we're running into in terms of, say, energy use of these big models? And accountability. We want, again, when these models make mistakes, there should be ways to sort of have a recourse to appeal these decisions and to hold the models or the companies responsible for the mistakes when they happen. So AI governance just really is just another thing of terminology. We're talking about the same kind of thing, and it's not just how do governments deal with AI, but companies, organizations. How are you going to manage AI in a responsible way in your organization? Ethically, transparency, taking into account all these sorts of things I just talked about. So this is really what, again, you think about your own organization, your company. How is it that you're going to manage AI effectively for yourself? So I talked about some of the things that AI can sort of generate inappropriate sometimes. One things with generative language models you hear a lot people talk about are guardrails. So, we want to say that if somebody goes to generative AI and say, how do I make a bomb? We don't want it to answer questions like this, maybe. Also, you might ask a benign question, but it might accidentally produce something inappropriate. We want to make sure it doesn't do that also. So how is it that we can, sort of try to, as much as we can, mitigate these kinds of problems? Very difficult. What we love about these generative models is they can produce anything. What terrifies about us is they can produce anything. So we try to do what's called red teaming, where we try to find lots of problems so in advance so we can fix them. But even if you're using a proprietary AI system that's going to have these kinds of guardrails, anybody can get one of these open source models that doesn't and run it on their own. So there's real challenges in terms of trying to prevent this stuff. But there is a big difference between whether you're using open source or proprietary models. One of the other things that's really important in responsible AI is diversity and inclusion, which we've talked about for years, but it means kind of a whole different thing in this case. A lot of the problems we've had, say, for instance, when a camera isn't able to recognize people with darker skin tones, or an image recognition system misrecognizes certain races as animals. A lot of these things might get through. The problems might happen because they never had enough eyes on the data looking at this and thinking about this from other perspectives or designing appropriate test cases. So diversity and inclusion isn't something you just do to sort of fulfill quotas. It's something you do because we're a diverse world. And if you want to build the best products, you want to have people from all those diverse backgrounds who are going to help you think up the best products and who are going to help you think up all the test cases that might impact all these diverse people out there in the world. So the way we make sure we have diverse data, responsible data, is by having diverse eyes on the data to begin with. So back to UT at Good Systems. we are very big and we have over 120 researchers, over 30 departments across campus. We really think you can't leave AI to technologists alone to do everything. And as I just talked about diversity, we really think diverse expertise and perspectives are required for responsible AI. So we have 6 core projects, and I wanted to tell you in particular a little bit this one. So all of our projects are really driven by societal problems where we're trying to look for opportunities for where AI may pose risks and opportunities. And so the project I want to talk to you about is the one that I'm leading, where we're really looking at sort of safeguarding our information environment. So besides this example I gave you of sort of a fake image, here's a sort of fun example. A couple of professors sent tens of thousands of letters to state legislatures that were split between generated AI and real AI. And essentially, all of the politicians responding to these wouldn't really differentiate, couldn't tell the difference between sort of these letters. This idea of sort of fake content isn't just something we in the public see. This could really have significant implications for sort of how democracy works and the ability, say, for politicians to interact with their constituents appropriately. So, we have to think about, if you're going to potentially be able to flood officials with not only fake letters, but fake phone calls. For instance, you can imagine right now there are robocalls where we've told people trust your local election official, but you might get a robocall from somebody who sounds like your local election official telling you, oh yeah, elections moved back a day. You don't need to come. I was, reading a blog post here by the Bipartisan Policy Center, and you get to the end of the blog post, and they say, "By the way, this article was written by AI," and you might not realize it. I didn't until the end. I think the one that was most striking for me was I was invited to address a new committee on AI in my state government, and they opened with sort of statements from all the members of the committee, and it was recorded. And we listened to all of them speak, and then they said, by the way, that wasn't us speaking, that was all AI generated examples, and this is the world we're in right now. So here's one of the articles that gave me the most worry. So you can imagine that with sort of fact checking in general, we can handle things when given time, but what happens when we don't really have time? Say the day of an election, we have this sort of attack. So we have a closely conducted presidential election. There's a disinformation campaign designed at suppressing votes. The automatic AI is really good at kind of helping us maybe detect an emerging attack, but really we need to have people in the loop, or what's called human in the loop, to really kind of keep track of what's going on and respond appropriately. And just for most topics and events, there just simply aren't enough people who can respond fast enough to deal with this. So this is one of the real challenges is we have is these kinds of real-time attacks that we don't have time to respond to. Another one that I think is really not commented on enough is that because now there's so much stuff out there that's potentially fake, anytime I, as maybe an elected official or a candidate running for office, do something bad, I can just say, that wasn't me, that was fake. And there's this deniability for anything because we just have so much trouble now telling what's real and what isn't anymore. So we're talking about this a lot today, but I want to point out, there's long history around this kind of stuff, so first of all, going back to 2009 Information Literacy Awareness Month, we have this crisis of authenticity being talked about by President Obama. Anyone can publish or say anything. What we loved about the web, what people talked about originally as Web 2.0, is the fact that anybody could publish anything online. We didn't have the same barriers anymore. But when anybody can publish anything online, then we do have these challenges for sort of for accuracy of information. So this broad phenomenon of information disorder is much older. As long as we've had human civilization, I think we've had sort of misinformation, disinformation sort of being spread. But what's really being challenged now is sort of the scale and the speed of this stuff. And that's what really technology, I think, is changing a bit. So the project I'm leading, it's called Designing Responsible AI to Protect Information Integrity. We're really focused on serving professional fact checkers from around the world. We've conducted interviews and co-design with a lot of these international fact checkers. We're trying to build sort of fair and explainable AI technologies to help them do their work more efficiently and effectively. So here's kind of a simple graph. We can see that on the bottom, the solid black line is sort of the scale of stuff the professional fact checkers are able to check. And the dashed line is all the crap that's being generated out there in the world. And you can just see this gap is only widening sort of between them. And this was back in 2016, so only worse now. So one of the challenges is really how we think about scaling up the work of this. And this is both deciding what to fact check, as well as conducting these fact checks appropriately. It's interesting for some of the stuff that's really fringe, fact checkers intentionally don't check it because even to check it is to give it legitimacy and to give it maybe greater awareness and circulation that it would have otherwise. So there's challenges in just choosing what to fact check, let alone how to do it. So generally, one of the things we're trying to think about with AI broadly is how we sort of coordinate AI and human to work effectively together, how we can build human AI partnerships or teams such that the whole is greater than the sum of its parts. And so one of the examples I want to give of sort of something in this space is when we think about fairness or responsible AI, when a fact checker chooses what to fact check, one of the sites, for instance, had their policy originally posted until a year or two ago as basically they would check whatever the most people asked about. Well, this is utilitarianism, Jeremy Bentham, the greatest good for the greatest number, which is wonderful if you're in the majority, but potentially sucks if you're in the minority, because some of the stuff that may be impacting you the most severely isn't what most people are asking about. So one thing you have to think about as a fact checker is not only what's going to be of the greatest interest to the most people, but are there some people who will be disproportionately impacted? And as we start to deploy AI technologies, we have to worry about all these same kinds of things. And again, if we just look at what the statistics tell us is most common online, we might miss out on a minority of things. So this is one of the things where we have this complication in trying to think about how we build this human AI team to do something effectively, but do so in a very sort of responsible way as well. So that's where I was going to wrap up today's talk. I think I finished quite a bit ahead of where I was. I do have lots of bonus material if people want to ask about anything. But so the main things again, I just really wanted to tell you a bit about was I know there's so much excitement about generative AI in particular, and there's great reasons for some of that excitement, but also reasons for caution. That if we have these kinds of unrealistic expectations, we are risking sort of this AI winter of this trial of disillusionment. We dug in from there to talk a little bit more about defining AI. We talked about AI, machine learning, deep learning, generative AI, things like supervised learning, unsupervised learning. So a bit about how all this stuff works, guessing words for language models, but also some of the challenges we really have, whether it's training on bad data that has inappropriate content, having supervision from people who are potentially being exploited in certain ways in the third world, for example, intellectual property problems with how we're getting the data to train these systems. And then I shifted gears and I talked about sort of some of the challenges we have of the harms AI can cause in the world. We looked at a bunch of different examples. Some of the things we're doing in UT in particular in good systems, we're trying to think about responsible AI and AI governance. And then I did a further deep dive in really trying to talk about a specific project that I'm leading, where we're really trying to say, not just how can we make responsible, fair AI in a vacuum, but really think about societally pressing problems and how we can use that to ground our work as AI researchers. Something we often talk about is what's called use-inspired research, which is I don't just work on an AI problem that I think is just interesting from first principles. I try to say, here's a problem I have in society. What can AI do and where is AI falling short? And then where is falling short? Is there a technology I can develop there that will be broadly useful for advancing the field in AI, but also help me serve this particular societal challenge and move forward? So we've been looking at this in the context of this protecting the information environment, which I know with an election coming up in the United States and so many elections around the world this year is really pressing for a lot of us in democracies. I also think as educators, not only are we having to think about, of course, AI literacy for our students now, but also the general challenges of information literacy that have a whole new flavor, with the way technology is being used to generate and spread information this day today. So I think there's a lot of really interesting things there for both AI and, again, information literacy more broadly. So with that, I'm going to just wrap up, say a couple quick things. And we have this year of AI happening at UT with a lot of really exciting stuff where we're trying to think broadly about challenges and opportunities of AI in the world. And then I've mentioned good systems in particular, which Kathleen kindly mentioned in her introduction. So we have this campus grant challenge where we're really trying to do a lot of interesting things around trying to design, build, and test a future of responsible AI technologies. So with that, happy to take any questions, and thank you so much for having me today.
Thank you so much, Dr. Leese. That was such an outstanding presentation. I've taken pages of notes. You're giving us so many layers and layers to think about. I know there are some Q&A. There's a question in the Q&A chat. It says the effort of alignment seems like it could reduce bias or increase bias depending on the ideology of the human doing the alignment. Can you talk about the ideologies that are most common amongst humans that work in the field of alignment? Are those communities broadly educated or more ideologically unwieldy like Elon Musk?
Yeah, so one of the sayings we've pulled from a researcher from the University of Washington, I apologize, I'm not remembering her name right now, is that technology is neither good nor evil, but nor is it neutral. So when we build a lot of these technologies, it really depends a lot on who is doing the building in terms of what gets done at the end. So let me just sort of talk about a kind of a general example and then maybe get a little more specific after that. So I've done a lot of work in detecting toxic language or hate speech online. And, we might all have the same goal. We want to protect people from what's being said out there and from harm. But who decides whether a given post is inappropriate or not? We've had lots of debates around free speech and different platforms that sort of cater to different levels of free speech or moderation. But there's even more subtle questions like, for instance, a given post. Well, let me back for just a second. One thing we've seen was that when people talk in a certain dialect, annotators, human data labelers who look at this are more likely to think it's toxic than people who are from that community and know that vernacular and dialect and do it. So we have a lot of problems when we have a subjective annotation task, a subjective decision we want our model to make, and we have to think carefully about who it is that we call upon to help us think about what the right decisions should be in those cases. So in this case of toxic language, if you want to think about how toxic language is impacting a particular minority group, you might want to have people from that minority group actually involved in looking at the data and helping you make decisions responsibly about this. So to come a little closer, I think, to the question, I think you have different levels of answers here. So the companies themselves, ultimately, they want to sell products. They want to make money. They want to build products that are good, that people want to buy. They don't want to get bad press. They don't want to get sued for causing harm. So they're certainly doing the best they can internally to try to do this. But they're still driven ultimately, typically by capitalism, by the bottom line. Then you have governments. Governments are also trying to maybe make sure that certain groups get more protection that capitalism wouldn't necessarily cater to. So we do a lot, again, sort of protecting minority groups, even if they don't spend the most money. And so you might think about policy or regulation we have at the government level about trying to sort of ensure that certain protections are in place. Challenges is typically governments don't know enough about these technologies to often regulate or write policy effectively, which is why, for instance, here in Texas, we've had a lot more great interaction, with the government having a sort of committees, reaching out to academics, having sort of advisory boards, trying to get that expertise, back in. So the answer is lots of different people want technology to do lots of different things. And also, sometimes even when you have good intentions, it might be hard to get all the right people involved. It might be easy to have oversights, but absolutely, who is involved in this, who has the steering wheel, is going to help drive where the technology goes. And so we do want to be thoughtful about who are the people we're putting behind the wheel to make those decisions for us.
Excellent. There are a couple of other questions in the chat. One is, will these AI challenges create a new winter 3 of AI?
I think, again, this is one of the greatest fears we as AI researchers have, in that, of course, we love to think about and imagine the future of this technology. We want to build the best technology we can to serve society. And we do think there's real capabilities and opportunities here. But when people have really unrealistic expectations, then we'll never be able to meet them. And then people might be dissatisfied and turn away from this stuff and stop investing in it, or, focus in other areas. So I think it's all about sort of calibrating expectations, setting realistic expectations for what it can do. And at the same time, we also need to be very wide-eyed about the harm it can cause in the world. That any kind of technology, whether it's AI or anything else, as it becomes more powerful, more ubiquitous, has risks of harm as well as benefit. And we just need to be really good stewards and being really thoughtful, being proactive ahead of time and trying to anticipate these problems and challenges, such that we can prevent and mitigate these risks to the extent we can.
Excellent. Another question is, what guardrails are in place for the Good Systems program to keep it removed from state government influence or directives, given that UT Austin is a state institution? How can other institutions protect their autonomy as well?
Yeah, so I think in general, as a state university, we certainly have a lot more interaction, say, with our elected governments and state officials than you would at a private university. Ultimately, universities do have free speech. This is one of the reasons why the system of tenure was invented. For those who don't know about it, during McCarthyism, when we had a lot of concerns about communism in the country, and there was a lot of political suppression of speech at universities, the notion of tenure was invented to ensure that academics could have free speech in spite of that. Tenure is certainly under threat broadly in America, and we do have lots of tensions and challenges around being able to speak truthfully around this. And I think the question is sort of a good one. We should continue to ask. I think that said, while there are certainly always risks of politics steering us in ways we don't want, I've been incredibly impressed by some of the interactions I've had with my state legislature in Texas, where we might not see eye to eye on every single issue, but overall what they want is really to think about how to be thoughtful stewards of AI technology to make sure that we can harness all these benefits for the economy, to benefit people, at the same time protecting privacy, um, or certain kinds of other risks. So I think, sort of, if you think about any kind of effort you want to undertake that takes more than one person, you always have to work with people to understand where you have areas of intersection and try to work together in those, build shared purpose initiatives and tackle those. And there'll always be a challenge that people don't see eye to eye on everything. And then we just have to work even harder to try to find good ways to sort of design things that we all feel collectively good about.
We might have time for one more question. I see one in the Q&A. At what point are we going to be able to trust AI? As an educator, the only AI I'm seeing is that of students presenting ChatGPT as their homework. It's disappointing and discouraging, but I love the potential of AI. I just don't trust it, and I see more maliciousness than not.
Yeah, great question, and lots of different sort of flavors of this. So, for instance, at my own university, we're not having a university-wide policy on you can't use AI or something like that. What we're doing is we're trying to empower all of our teachers with lots of different ways to think about what's the appropriate use policy around AI in their classroom. So in some classes, it might be totally inappropriate. In others, you might think of a creative writing class where, for instance, maybe you'd want to have challenge students use this. We often talk about the metaphor of a calculator. So, at one point, we had to bring our slide rule into math tests. Now we often feel good about using a calculator, but it took a while for us to think about and what was the appropriate use of it, and maybe when students still need to show their work and when they can use the calculator. So I think what's challenging a lot is just so much has happened so quickly that it's caught a lot of us kind of flat-footed, and we're trying to think about, what is it that makes appropriate use of this kind of stuff. So I think educationally, I'm certainly not a professor of education. I won't speak to expertise in that area, but I think there's definitely a lot happening at my university and others where we're trying to think about what sort of appropriate uses. But the broader question, I think, was about how we're going to learn to trust AI. And that is another great and very complicated question. But let's think about something like flying, for instance. So whenever we as academics attend conferences, often we fly somewhere to do it. How often do you worry about when you're getting on the plane, whether or not it's going to safely arrive at your destination? Or just driving in your car to work each day, you probably are at a much higher risk than when you get on a plane. How do you know that your car, you're going to arrive safely at work that day? I think there's a lot of things just in terms of safety, consistency, predictability, that make us trust systems. We also are thinking a lot in AI around what terms like transparency, explainability, interpretability, in terms of understanding enough about the system to be able to work effectively with it. Now, like probably most of you, I drive my car to work often, but I don't really know anything, honestly, about how my carburetor works or anything else like that. And yet I can still get behind the wheel and press the brake and the gas pedal, and get to where I need to go. So you don't need to know everything about how AI works, but you need to know like just enough. So I think that's what we're trying to figure out is what that just enough is, such that you have transparency and understanding where you need it to work with it effectively. And so let me give one like closing example on that, and then I'll stop. So when we use a search engine like Google, I mean, most of us don't really, again, know anything about how it works behind the scenes, but we have an idea how when we formulate our query, if we do or we don't get good results, how we change our query to get better results later. That's the kind of like transparency I think we might need to understand here is, okay, if I'm using an AI and I'm coming up with a prompt to generate something and I'm not getting what I want, how is it that I can play with the prompt or modify it or adjust it to get the kind of output I'm looking for later? That will give me the sense of autonomy and control to be successful and to have sufficient confidence I'm not going to get these kinds of inappropriate outputs or harms that I'm trying to avoid. But yeah, definitely a great open question that we're working hard on.
Well, thank you so much, Dr. Matthew Lees from University of Texas at Austin. This has been
Pleasure.
such a robust, thought-provoking, informative session. We really appreciate you. We appreciate you being a keynote speaker. And we thank everyone for attending and asking great questions. This is a good time for a short break as the next session will begin in approximately 15 minutes. Thank you again.
My pleasure. Thanks, everyone.